Hello. This video is some select problems from page 519, which was section 8.4. This was the word problems with angle of elevation and angle of depression that become trig problems for you to solve with trig. All right, so first thing you do is, this one was drawn for you. You identify that given angle. I always circle it because I want to pay attention to it. And then based on that angle, I label the sides that I've been given. Across from that angle, this is called the opposite side because it's across from the angle. And then the right angle always points to the hypotenuse, so this is hypotenuse. I do not label this side right here because it's blank, so it has nothing to do with this question. And then if you look at our little acronym, some people write it like this, SOHCAHTOA, like that. You pick out which one will solve this problem. We have opposite and we have hypotenuse, opposite hypotenuse, so this must be a sine problem. So you write sine. The angle always comes next, and then you write the definition of that trig ratio. In this case it's sine, so opposite over hypotenuse. And then you cross multiply and this gives you your answer. So x is approximately 100 times sine of 20, so you grab a calculator and you do 100 times sine 20, and your calculator does that for you. It is 34.2. So x is approximately 34.2 feet. That is how to do number 17. Number 19 was a word problem, so I'm going to draw it, and when you get the drawing done, there's a triangle that you will use trig to solve. So it says there's an angle of elevation of a weather balloon. I don't really know how to draw a weather balloon, but I think it kind of looks like a blimp. So I'm going to draw a blimp. There's another problem later on that's a blimp, but let's just pretend it looks something like that. It says the angle of elevation of this weather balloon is 41 degrees. It says there's a meteorologist and he's measuring this angle. So if you read further in the problem, you find out he's on the ground because it says the angle of elevation that he measured, and they want, later on in the problem, they ask you for the distance to him. So that implies that he's on the ground and he measures this angle of elevation. Here's where an angle of elevation would be, 41 degrees. And it says a radio signal from the balloon says that it's this many meters, 1,503 meters from this meteorologist's location. Here's the camera. Or, no, it doesn't say camera. That's on the other blimp problem. It's a radio signal from that blimp. The reason they tell you radio signal is because that's what allows us to measure something going through midair. It's because it's a signal. So that's that distance right there. And the question is, how high is this weather balloon? Always put the X where the question is in the picture. So they're asking us for how high, that's why I put an X right there. If you don't put that X right there, then you don't know to figure out what side that is. Like you won't recognize that that side is part of the problem. So, because you'd have a missing measure there and a missing measure there, and you wouldn't have identified which one you're talking about. All right, so here's your angle. Across from that is opposite. This is across from the right angle, so this is hypotenuse. So this is just like that last problem. It's a sine problem. Opposite and hypotenuse is sine, so you write sine, angle always comes next, equals opposite over hypotenuse. And so when we cross multiply, 1 times x is x. We're going to do 1503 times sine of 41. 1503 times sine 41. You get 986 meters. 986 meters. Okay, number 21. Number 21, see how this angle is up there? That means it's an angle of depression. Angle of depression questions are a little bit harder because that angle is not what's called our working triangle. This is our working triangle right here. And that 18 degrees, I think I said 81, but that 18 degrees up there is not in this triangle. So what we need to do is pick that angle up and move it down here, those are called alternate interior angles. You can move that 18 degrees to right here. There is another way to do this problem. Instead of moving the 18, you could have calculated this angle, because they add up to be 90, and then you could have used that angle, which would be 72. To me, that's just another opportunity to make a mistake with that math right there, that subtraction. It's not hard, but just another opportunity for something to go wrong. So I would rather just move it to right there. All right, so here is my angle. Across from the angle, this is opposite. This is right next to the angle, so this is adjacent. Opposite and adjacent, if you look at our acronym, the one that has O and A for opposite and adjacent is a tangent problem. So this is tangent. Tangent of the angle equals opposite over adjacent. And so then we solve this. Put that over 1, cross multiply. 1 times x is x. You're going to put into your calculator 2 times tangent 18. 2 times tangent 18. You get 0.65. You can round that to 0.6. So we round to this place. That if it was a 5, it would round that up to a 7. But since it's a 4, it leaves the 6 a 6. So 0.6. 0.6 kilometers. All right, number 23. It says the tallest flagpole in the world is 282 feet tall. 282 feet. And the shortest shadow of that flagpole is 137 feet. And they want the angle of elevation of the sun. So if the flagpole is here and our shadow is here on the right, that means our sun has to be back here. It's kind of like that tree problem in the notes, that angle of elevation of the sun when we had drawn a tree. All right, so if the sun's over here, this is where the shadow would be, and the angle of the sun, angle of elevation of the sun, would be like this, because the sun, from our perspective, starts at the ground and rises like that. So we're looking for that angle of elevation. All right, even though I don't know this angle, that is, that's our reference angle. And so across from the angle, this is opposite. This is next to the angle, this is adjacent. And so opposite and adjacent, if you look at our acronym, that's a tangent problem. Tangent of the angle. Angle always comes next, even if we don't know the angle, it comes next. Equals opposite over adjacent. Okay, whenever the angle is unknown, whenever the angle is missing, you do not cross multiply. You don't put that over 1 and cross multiply, because you're still going to have a tangent of x. We don't know what the tangent of x is. So what we have to do is get rid of the word tangent. And so to get rid of the word tangent, you do tangent -1 on both sides. Tangent -1. And so that cancels and we have x. So whenever the angle's missing, what you actually type into your calculator is second and then one of these ratios. This one's a tangent. And then you type in this fraction. 282 divided by 137. About 64 degrees. Okay, last problem from page 519. And these are just ones that I picked out. I don't think this is the whole assignment. I think these are just ones that I picked out. All right, so it says the line of sight distance from the camera to the base of the stadium is what they want. So this is this camera blimp. So there's a camera there that's doing some overhead filming. And they want to know this line of sight distance to the stadium. That's our X. So one thing I noticed that students do when they have trouble with this is they just forget to label the missing side with X. And so then they've got too many unknowns. They've got this missing side and they've got this bottom of the triangle that's missing, and they don't know which one to use in terms of sine, cosine, or tangent. So always put an X in word problems where that unknown value would be. All right, this one's kind of like number 21 because that's an angle of depression. So we have to take that angle and move it down here. See, it's not in our triangle. Here's our triangle. And the 7 degrees is not in it. So we have to grab that angle and move it down here. This angle of depression matches this angle of elevation. And then we decide what kind of problem this is. This is the opposite side. This is the hypotenuse because the right angle is pointing to it. So this is the hypotenuse. Opposite and hypotenuse, this is a sine problem. So you write sine. Sine of 7 degrees is equal to opposite over hypotenuse. So I'm kind of glad this one looks like this. This is the first one in this lesson that has X on the bottom. And so when you cross multiply, it looks a little bit different. So when you multiply here, X times sine of 7 can't actually be done. We just write it. X times sine of 7. But this can be done. 1 times 400 is 400. See, we're trying to get X by itself. X is multiplied by the sine of 7, so we have to divide by the sine of 7. So what you actually type into your calculator is 400, normal number first, divide by sine of 7. 400 divide by sine of 7. And you get 3,282. 3,282.2 let's see, meters. I forgot to look at the problem when I looked it up of what they wanted it rounded to. So that's what it would be rounded to the 10th place. If they wanted the nearest whole number, it would be 3282. And if they wanted the nearest hundredth, it would be 3,300 because that 8 would round that to a 3. So 3300. So if they want it to the nearest hundredth, it'd be 3,300. Okay, so those are some problems from page 519, the lesson on angle of elevation and depression. Thank you guys.